You're a dental student, third year, maybe fourth, and someone, a professor, a supervisor, a colleague, just told you to read a paper. So you sit down, you open it, and you start from the top. Title, okay. Abstract, manageable. Introduction, you start losing the thread. Methods, what is a confidence interval? Results, tables, numbers, p-values, discussion. You're just reading words at this point. So you close it. Tell yourself you'll come back to it later, but later never comes, and the paper stays unread. Here's what nobody told you. The problem was never the paper. The problem is that reading a scientific paper is a skill, and like any skill, it has to be taught. Nobody just picks up a scalpel and operates. You learn the instrument first. A scientific paper is not a textbook. It's not a story. It's a structured argument. Every single section has one job, and when you know what that job is, the whole paper opens up. You stop reading and start analyzing. That's the difference between a student and a researcher. This series will take you through every section, one episode at a time. But before we go inside any paper, we need to talk about something more basic. Not all papers are the same. The first type is the case report. One patient, one unusual finding, no control group, no statistics. Its only job is to say, this happened, and the world should know about it. There are different types of scientific papers, and the type of paper you're holding changes everything. How much you trust it, how you read it, and what questions you ask. It's the weakest form of evidence, but sometimes it's the first signal of something that later changes an entire field. Next is the case series. Same concept, but instead of one patient, you have a group of similar cases. Still no control group, still descriptive. But having 5 or 10 similar cases is a stronger signal than one. Then comes the cross-sectional study. Think of it as a photograph. You look at a population at one moment in time and measure something. It's good for understanding how common something is. But a photograph can't tell you what came first, the disease or the risk factor. A cohort study adds the element of time. You take a group of people, you follow them forward, or look back at their records, and you watch what happens. You're getting closer to cause and effect, but you're still just observing. Now we reach the randomized controlled trial, the RCT. You take a group of patients and split them randomly into 2 groups. One receives the treatment, the other receives a control. Random assignment removes bias. This is why the RCT is called the gold standard for testing whether something actually works. And at the very top, the systematic review and meta-analysis. Not one study, a study of studies. Researchers take every available study on a specific question, apply strict filters, and synthesize all the results into one answer. The closest thing science has to a final answer. Put them all together and you get the evidence hierarchy. At the base, case reports. One level up, case series. Then cross-sectional studies. Then cohort studies. Then the RCT. And at the peak, systematic reviews. When you pick up a paper, the first thing you identify is where it sits on this pyramid, because that tells you immediately how much weight to give its conclusions. The paper hasn't changed. You have. Episode 2, the title and abstract. See you there.